Hi guys, these are the first notes of the new unit for chemical equations. This is for balancing chemical equations. I'm going to split this up into two videos. I think it's too long otherwise. So the first one is just going to be, how do I balance a regular equation? The second video is going to be, how do I balance polyatomics and combustion reaction? All right, so let's start with some notes you would need to know. Subscripts is the little number. That's this guy right here. This is a subscript, this is a subscript, and this is a subscript. If there is no little number after it, it's an invisible one. It tells you how many of that element only. Coefficients are big numbers in front of entire molecules. Okay, so there's a 2 for this molecule. There is no coefficient here, which means there is 1 of this molecule, and there are 2 of this whole molecule. If I want to know how much there is of each one, because you're going to need to know that, you would just multiply. Okay, so the number of each element is subscript times coefficient. So if I want to know how many H's there are, okay, I think I'm going to use this. How many H's there are, I would say this big 2 times this little 2, and there are 4 hydrogens on the left. If I want to check and see how many there are on the right, again, I would do this big 2 times this little 2, and there are 4 on the right. So the H's are balanced. For oxygen, I would say 2 times an invisible 1, and there are 2 oxygens on the right. Okay, let's do a quick review on how to figure out for how many there are for each. Let's just talk about oxygens, okay? I only want to know how many oxygens. So for this one, it's 3 times 3, so 9 oxygens here. 2 times 2, 4 oxygens here. There's no coefficient here, so it's just 1 times 3. 3 oxygens here. 4 times 1, so 4 oxygens here. There's no coefficient, so just 6 oxygens here. 4 times 3, which is 12 oxygens here. 2 times 8, which is 16, and 3 times 2, which is 6 oxygens. Again, that was only for solving for oxygens. Now, why is balancing important? The reason is because of this law right here, the law of conservation of matter. Matter is not created or destroyed. So you can't suddenly make something and you can't make it disappear. All right. So whatever you start with, you have to end with. So if you look at this picture here, we're going to take H2 molecules, we're going to add O2 molecules, and we're going to make water molecules. Okay. So if you count these up, you'll find that you've got 2, 4, 6, 8, 10, 12. You have 12 H's here, and you have 2, 4, 6, 8, 10, 12 H's on this side. So the H's are following the same rule. If you count up the oxygens, you'll find the same for the oxygens. Okay, so whatever I start with on the left has to be on the right. So everything has to be equal, balanced, okay? So here's the steps on balancing a chemical equation. Is first you make a tally. So you determine how many of each you have on the reactants, which is the left, and the products, which is the right. Then you can change coefficients. That is the only thing you can do. You can never change or take away or add subscripts, okay? You cannot mess with subscripts. It's like changing a recipe. You can't suddenly say, instead of salt, I'm going to put sugar, or instead of sugar, I'm going to put salt. You just can't, or you're going to have something different. And this is a little hint, which might save you some time. You're going to want to change pure elements last, okay? Meaning like O2 or Br2 or S8. Those are pure elements, okay? It just helps. The last step is you want to make a total and see, does it match? You want to check yourself. Did it work? So let's try this. So first step, I'm going to walk through slowly. In another video, I'll show you how to do the shortcut. All right, you're going to want to write this out, and then you're going to want to draw a line below the arrow. It has to be below the arrow because you are separating your reactants from your products, because that's the two things you need to balance. The two sides is underneath this arrow. So then I'm going to write out what I have. I've got H's and I've got O's. And I'm going to do the exact same thing on the right that I did on the left in the same order, even if it doesn't appear that way in the problem, just because it's nice to look back and forth. Oh, H's, H's, O's, O's. All right, so now I see on the left I've got 2 H's and I've got 2 O's. On the right, I have 2 H's and I have 1 O because there is no subscript here. My H's are good, 2 and 2, but my oxygens are not good. Okay, I have to change those. So The only thing I can do, unfortunately, I can't just put a little 2 there, because instead of making water, now I'm making hydrogen peroxide. So, and you know, the difference is that if you drink water, you live. If you drink hydrogen peroxide, you die. And that's a big difference. So I'm going to erase that because you can't do that. You cannot make or change coefficients. I'm sorry, subscripts. The only thing you can do is change or add coefficients. Okay? So if I need more on the right, then I am going to add a coefficient on the right. And the only thing I can add is a 2, all right? Because 2 times an invisible 1 gives me the 2 oxygens that I need. Now it also changes the number of hydrogens I have. Now I have 2 times 2, I have 4 hydrogens. So I need to go back on the left and fix that. In order to do that, I can add a coefficient of 2 here and say 2 times 2 gives me that 4. Now this 2 only goes with the molecule in front of it. This plus separates different molecules, so it doesn't also go with this oxygen. So I've got 4 and 4 and 2 and 2, and it is balanced. Now, the only thing that matters here is the coefficient. This is just the workup, okay? That's just to help you figure out what is the coefficient. But on Canvas, you would enter a 2 here. You would put a 1 here. If you're drawing it out, you would leave it blank, but on Canvas, you're going to have to put a 1. And then here, you would put a 2. Okay, so that would be the answer for that one. Let's try another one. So again, you're going to draw a line. And I'm going to write what I have. I've got P's, and I've got O's, and I've got P's, and I've got O's. Again, in the same order, so I can quickly look back and forth. It's going to get more complicated. So I have 2 P's on this side because of that 2, and I've got 2 oxygens on this side because of that 2. On the right, I have 4 P's, and on the right, I have 6 O's. So nothing is balanced right now. I have 2 and 4 and 2 and 6. So I need to change the left side because I don't want to add anything to the right side, and I can't take anything away here, so I can add coefficients to make it balanced though. So what times 2 would give me 4? I hope that you are saying 2, and that gives me the 4 that I need. And then what times this 2 would give me 6? And I hope you are saying 3. So now I have the 6 oxygens that I have. Again, this stuff is not important. It's these numbers that are important. So on Canvas, you would enter a 2 for this one, a 3 for this one, and you would put a 1 there for Canvas. Again, if you're writing it out, you don't need to put a 1 there. All right, let's try another one that looks a little more complicated. Again, draw out the line, and I'm going to write down what I have. So NaCl, it's a terrible C, Al, and O, and I'm going to do the exact same thing in the same order over here so that I can quickly compare what I've got. NaCl, Al, and O. All right, I got one of these, I have one of these, I have 2 of these, and I have 3 of those. I've got 2 NAs, I've got 3 CLs, I've got 1 AL, and I've got 1 oxygen. Okay, so currently nothing is balanced. It doesn't really matter what you start balancing. There are no pure elements here, so I don't have to save anything for last. Let's pick something randomly. Let's start with NAs. Sure, let's start at the beginning. Okay, so I have 2 NAs here. I need to have 2 NAs here. The only thing I can do is put a 2 coefficient here. That changes my NAs. It also changes my CLs. So let's just do that. Okay. I can already see that it's not going to work out with my CLs, but that's okay. I'm just going to keep going. A lot of this is just back and forth, trial and error. Okay, the next step is, let's change our ALs. Okay, I have 2 on the left. I need to have 2 on the right. So I can put a 2 here because 2 times 1 is 2. So I have 2 ALs, but how many CLs do I have? 2 times 3, I have 6 CLs. Okay. Let's move on to oxygens. I have 3 oxygens here. I only have 1 oxygen here. So how can I make it so that I have 3 oxygens on this side? If I put a 3 here, 3 times 1 gives me 3. 3. Okay? It also changes my NAs. So how many NAs do I have? 3 times 2, I have 6 NAs. Okay? So my oxygens are fixed, my aluminums are fixed, but my NAs and chlorines are, they need to be updated. So when you do this, okay, you are pretty much starting over. I'm not going to add to this 2. I'm going to change it to make it what I need, okay? So I no longer have 2 NAs and 2 CLs. I'm going to make it so that I have 6 instead. So I'm just going to put a 6 here, okay? And don't add what you had. It goes away. You're just changing it. So now I have 6 NAs and I have 6 CLs, and now everything is balanced. I have 6, 6, 6, 6, 2, 2, 3, 3. Okay, so in Canvas, again, you would enter a 6 for this one, you would enter a 1 for that guy, a 2 for this one, and a 3 for this one. All right, I'm going to stop here, and I'm going to address polyatomics and combustions in the next video. So make sure you watch that before you do the Canvas assignment. Okay, let me know if you guys have any questions.